if you're looking to combine these, adding and subtracting is the combining process. What you need to do is you need to know all the factors of your denominators first. So what I would do is go through and establish each of these denominators in terms of their factored forms. So the difference of two squares, x squared minus 4, factors into the sum and difference of the terms being squared, which are x and 2. Here are the two factors of positive 2, whose sum is negative 3, is a minus 2 and a minus 1. And then finally, here you have two factors of negative 2, whose sum is a positive 1, is plus 2 and minus 1. So here's your all your fractions written where you just have the factored form. So I'm not canceling those out. I simply rewrote them in factors. What you can now do is establish your LCD. So I'm going to go fraction by fraction, and I'm going to establish the LCD. So I know I need an x plus 2 and an x minus 2 from my first fraction. My second fraction, I need an x minus 2, which I already have. I need an x minus 1. I don't have that yet, so I'm going to include that. And then looking at my last fraction, I need an x plus 2, which I already have, and x minus 1, which I already have. So here's my three LCD factors. Now, if any of these denominators had multiples of a factor, you have to have at a minimum amount whatever those multiples are. So if there were two factors of x plus 2 here, you'd need at least 2 here as well. Okay, once you establish your LCD, what you're then going to do is go back into your original fraction, take the numerator of your first fraction, and multiply that by any LCD factors that are missing from this first fraction's denominator. It has the x plus 2 and the x minus 2. It was missing x minus 1. Minus the next fraction's numerator, 1, times any LCD factor missing from this denominator. This one has the last two factors. It was missing the x plus 2. And then finally take your last fraction's numerator, which is a binomial, and multiply that by any LCD factors missing from this denominator. It's missing the x plus 2 and x minus 1. Or I'm sorry, it has the x plus 2 and x minus 1. It's missing the x minus 2. Okay, so this was that second step. I rewrote this, or that first step. I rewrote this all as a single fraction. I'm now going to simplify my numerator. I tend to do that outside of the fraction itself. So I'm going to distribute my 2x here. That gives me 2x squared minus 2x. Distribute my negative 1. So minus x and minus 2. And then here I need to FOIL this. So I'm going to FOIL. I get x squared minus 2x plus x, and then minus 2. So here is my combination of terms vertically stacked in like terms. And if I combine these straight down the column, I get 3x squared. Here I get minus 4 minus 5x plus 1. Again, these kind of cancel. I get minus 4x. And then minus 2 and a minus 2 gives me minus 4. Now, what I don't know is does this expression factor? And the easiest way to test to see whether a trinomial with a leading coefficient, something other than 1, is factorable is do the process that you would use for rewriting the middle term. If I take my leading coefficient times my constant, 3 times a negative 4 is negative 12. And just identify, are there two factors of negative 12 whose sum would give you negative 4? Yeah, negative 6 and positive 2, right? If that happens, then you know these can be factored. Now, you can either factor them by trial and error, or you can use rewrite the middle term. Since I already did that step, I'm going to rewrite the middle term here. I get a negative 6 and a positive 2. I rewrite the middle term as the sum of those, drop my first and last terms down, and I factor by grouping. So I get 3x is the common factor removed from the first pair of terms, leaving x minus 2. A plus 2 is the second common factor I can remove, leaving an x minus 2. And so I take out my common binomial factor, x minus 2, and I'm left with 3x and plus 2 as my other set of factors. So all of this process is simplifying my numerator. I'm now going to rewrite this in its factored form up here all over, and now I'm going to put it back into its fraction. So x plus 2, x minus 2, and x minus 1. So this is now my fraction form. My last step is to cancel any common factors, reduce my fraction, so the x minus 2's cancel, and I'm left with a 3x plus 2 all over x plus 2 and x minus 1. Okay, so here is my simplified form. I also need to identify were there any factors that got canceled from the denominator that give me domain restrictions that are no longer apparent in the simplified form. I see that x can't be a 2. That's not apparent in this simplified form, so I have to include that as an additional domain restriction.